Okay, so we're gonna learn this technique. You're going to factor things that look like this. Remember, last week we looked at factoring 4 terms. You now have how many terms here? You guys know how many terms are here? 3. You count 1, 2, 3 terms. This is called a trinomial. So you're factoring a trinomial. Last week we looked at 4 terms, which we're factoring by grouping. There's 3 terms here. Okay? So anything that looks like this, I say looks like this, we'll talk about that in more detail. You're going to use this technique, this procedure. Okay, so you're going to say to me, what technique, what procedure? Well, take a look at this. This form is x squared plus a b times an x value plus some constant c. Okay? X squared plus bx plus c. I sometimes call this form chicken soup. Okay? And I'll tell you guys along the way why we call it chicken soup. Anybody know how to make chicken soup?
No, not really.
Boil the chicken.
What do you do? You boil the chicken. What else? Cut the vegetables. Put the vegetables in. Put your seasoning. So is there a procedure you have to follow to make chicken soup? Has anybody ever made beef stew?
I just get it in a can.
Well, I'm talking making it. Is there a different procedure for making beef stew? What do you guys think? I would say it is. Why? Because there's chicken versus beef. But is it a similar recipe? Probably. So what I want to show you guys is you have a recipe here to factor things that look like this. X squared plus bx plus c. So for example, they say to you the following. They want you to factor, let's say, x squared plus 11x plus 18. This is a chicken soup recipe. You say, how do I know? Because this is x squared, see that there, plus what? A bx value, in other words, a power of 2, now a power of 1, and then a constant. This is, just looking at this, we identify that this is what we call chicken soup, I guess. Okay? So x squared plus 11x plus 18. All right, you guys okay with this? This is an example here. You're going to follow the procedure. Here's your procedure. Step 1, you boil the chicken. I'm going to say this. Step 1, you're going to determine the values of B and C. Okay, can anybody tell me what the values of B and C are? Well, what is B anyway? Isn't that the number multiplied to x? So B is 11. Good. You can tell me, Mr. Judge, B is 11. Okay. What's the value of C? Well, isn't C the constant, the number? So what is C going to be? 18. Does anybody have any questions on the procedure so far? All you're doing is using your eyesight, telling me what number is multiplied to the x, we call that B, and what the constant out here is, we call that what? C. Is that true? Okay, you guys okay with this? You're now ready for step 2. Step 2. You are going to determine a pair of numbers whose product is C, but whose sum is B. So you're going to find a pair of numbers. What does a pair of numbers mean? How many numbers is a pair? 2. Is that true? Two numbers form a pair. So you give me a pair of numbers whose product is C, but whose sum is B. So in this problem, the product has to be what number? 11 or 18? Do you guys know? The product has to be what number? C. So the product has to be 18. And then the sum, what does the sum have to be? 11. In my experience, probably the hardest part is for people to do what I'm saying right now. Find a pair of numbers whose product is 18. What does product mean anyway? To multiply. And what does sum mean anyway? Add. Do you guys know that this technique in factoring, the hardest part for people is going to be finding that pair of numbers? And you say, why is that? Well, in other words, notice. Don't you have to know arithmetic to do algebra? It's an arithmetic issue. Okay? So let's think about this, right? What two numbers? This is the key step right here. I'll put this here as your key, and I'll show you why it's your key. What two numbers multiplied together is 18, but when we add them is 11. What is it? How'd you do that so fast? Is it 9 and 2? Is that true? What's 9 times 2? 18. Let's notice. Let's check. I don't know. You guys did that too fast. 9 times 2 is 18. That's a product. What's the sum? 9 plus 2, and that's 11. Oh, you're right. This is the pair of numbers. 9 and 2 is the pair. You guys know something? You should be very, very happy right now. Do you guys know why you're happy? Because you're done. I'm going to say step number 3, write your answer. Now, your answer, ladies and gentlemen, has a certain form. It's going to be X, put your pair of parentheses. You see, factoring, we talked about last week, was the reverse of what? FOIL, or the distributive property. So this is my X times X, my first term. Do you guys know what you just found over here with 9 and 2? This is the last terms. The values you put here. In other words, that 9 is what? Isn't that 9 positive? That 2 is also what? So you found, ladies and gentlemen, you factored this. You're done. This is your answer. It's X plus 9 times X plus 2, because factoring is the reverse of what? Of FOIL. Okay? Now I'm going to notice, I'm going to prove this to you. I'm going to say no. No, that factoring is the reverse of FOIL. And you'd say to me, what are you talking about? How is that the reverse of FOIL? If I use FOIL here and I multiply this, my first terms multiply together is x squared. My outer terms, multiply these, plus 2x. My inner terms, 9 times x. My last terms, 9 times 2. If I simplify by adding like terms, what's 2x plus 9x? Isn't that what we got to begin with? Okay? So to verify here for you that factoring is simply the reverse of FOIL, it is. Okay? So you're going to follow this procedure if anyone ever asks you in your life to factor this what? Chicken soup. Okay? You follow that procedure. Now, in Math 125, those of you that move on to 125, guess what? Are they going to review factoring? No. Are they going to expect you to be able to factor? Yes. So how many factoring problems do you guys want to spend your time doing? I would say, you see your homework already? That says 5.27 to 61 all, and then the factoring handout that we're working on, that's another 40. That might not even be enough. That's almost 100 factoring problems. And you say, why should I do 100 of those problems? Because when you go to what class? 125, or even not just that, any class after, they will use factoring. Even college algebra uses factoring. Math 260 uses factoring. Anything higher than 125 or above, you will use factoring. So you want to invest your time and energy into these what? Into your chicken soup recipe, because it's good for you.
We pass the class, can we practice these on our winter break?
You can practice them anytime you want. In fact, I would suggest you practice them Thanksgiving. Anybody gonna have a Thanksgiving dinner? Guess what? Take a 5-minute break to eat turkey. Spend the rest of the day doing what? Factoring. Why is that? Because it's going to help you.
I'm gonna volunteer though.
You are going to take your math book.
I'll be busy though.
Okay, well, then take factoring next semester. All right, here we go. Let's see what you guys think of this. We're going to practice this procedure, ladies and gentlemen. So let's take a look, okay? This is all about your procedure. What's your first step? All right, what's the values of B and C? Let's go through this, right? I got x squared plus, there's an x. What's the value in front of that x? Is that a 1? So what would you guys say the value of B is? Is B 1? Sure is. What's C going to be? First step. What's the second step? My product now. What does my product have to be now? The product needs to be what? Negative 42, and the sum has to be positive 1. So I need a pair of numbers, two numbers, multiplied together is not just negative, but negative what? 42. Do you guys know what that means? The only way you can multiply a pair of numbers and have it be negative is if what? One of the values is negative. Because a positive times a negative is a what? A negative. What if they're both positive? Positive times a positive is positive. That's not what we have. We have a what? Negative. Okay? What's a negative times a negative?
Positive.
It's positive. Okay, so what's the pair of numbers? What do you think? What is it? How'd you do that so fast? Huh? You just, I mean, is it true that it's 7 and negative 6? Is that true? How would you tell somebody, how would you show somebody how to do this? Because there's people in this room, they're looking at you like, how did you get 7 and negative 6? There's no way in the world I could have got 7 and negative 6. Well, how do you go about this in case you don't know what the pair of numbers is? I mean, some people will know because you know what they did in their brain? They went through some multiples, or I shouldn't say multiples. They went through some pairs of numbers. So what I would say to you, if you're having a little difficulty, do this systematically. You say, what are you talking about systematically? Be systematic about what you do. Don't be arbitrary. Most people who are ineffective at doing these things are arbitrary. Do you guys know what that means? No. It means that they pick any pair of numbers off the bat. I'm not saying that's a bad thing, though. But if you're really problematic, you want to go with the system. So you might say, okay, 1 times negative 42 is negative 42. But what's the sum? Isn't that negative 41? If I put the sum over here, here's my product. I'm going to do this systematically. 1 times negative 42 is negative 42, but that's not the right sum. I need a sum of a 1. And then they go to 2 and say 2 times negative 21. Is that negative 42? Yeah. What's the sum? Negative 19. Is that what I'm looking for? No. And then 3 times what is negative 42? Is that negative 14? What's 3 plus negative 14? Is that negative 11? And then what's 4 times negative 40? 4 times a number doesn't even give you negative 42, right? What about 5? What about 6? 6 times negative 7 is negative 42. But then what happens when I add these? Don't I get what? Negative 1. And then that's a hint. Because you go, I'm opposite. This sum has to be a positive one, not a negative one. Ladies and gentlemen, you're almost there. You know why you're almost there? Because remember, one is positive, the other's negative. If I check now, switch the signs. If it's negative 6 now times a 7, isn't that also negative 42? What's negative 6 plus 7? 1. This is your pair of numbers. So, all I'm saying to you is that if you have a lot of difficulty finding that pair, and some people are in that boat, I would say do what? Go about this in a systematic way. Start with 1 times a number. Hopefully there's a number. There will be because it's 1. And then 2 times the number. Hopefully that'll work. Go down till you exhaust, get up to the number itself. You'll see what we're talking about. But this is where people, when I teach factoring, the people that have the most trouble or the hardest step for them is the key step, which is step 2. Finding the pair whose product is C, but whose sum is B, that's going to stop them in their tracks. And notice if you get stopped in your tracks, could you ever do step 3 then? Never. So, what's the final answer for this one? X, what is that? Plus 7 times x minus what? 6. You factored. And this is what I call the what? This is your chicken soup recipe. Okay, you're going to get beef stew, not today, but you'll get it eventually. All right, anybody have any questions on the recipe, on the procedure?
So basically to get 42, you just gotta pick like random numbers to get...
I didn't say random. We did it what? Systematically. See what I'm saying? I didn't say we randomly chose the numbers. What did we do? We went through this what? Start with 1, start with 2. Systematically. That's the opposite of really, in some sense, randomness. There's an order or an approach to what you're doing. Random would be if I said, 3 times what is the negative 42? Negative 14, okay. And then how about 14 times, I guess negative 3, that's okay. Maybe a 2, that's randomness. Maybe a 3. You might want to approach it in a systematic way. And like I said, there's some people who do it randomly. They think about everything randomly. Okay, can I erase this? You have your recipe? You're going to go home and make some chicken soup? Do that for Thanksgiving. It's coming up. You have turkey and chicken soup for Thanksgiving. So let's see some more examples here. I'm going to erase this portion. Okay, and like I said, the key now for you is to go through this recipe how? Over and over and over again. How many times? Maybe even 100. Okay, so all of these problems are going to be this chicken soup recipe, this factor recipe. So let's factor. X squared plus 10x plus 16. What's your first step again? Do you guys know what I kind of do when I go through this way? I'll go through and label this number 10. What is 10? B, good. What's 16? C, good. So I tell myself, C is 16 and B is what? 10. I always list C first because this is where I'm looking for my what? My product. And then B is my what? my sum. So I got to think, what two numbers multiplied together is 16, but when added is 10? Huh? What is it? Okay, 8 and 2, good. How'd you do that so fast? Did you guys do that really fast? How'd you do that?
I first found the value of 16.
Yeah. Let's see, 8 times 2 is 16. What's 8 plus 2? 10. Again, what do you tell people that say, oh, Mr. Judge, this is impossible. I can't do this. How do I start? I would say, okay, the number 16, right? 1 times what number? Right? Doesn't the product have to be 16? Isn't 1 times 16, 16? What else? 2 times 8, is that right? What else? 4 times 4, is that true? What else? 5. No. 6. No. 7. No. Then you get an 8 times 2. Wait a minute, I'm duplicating the pair. I don't need to duplicate the pair. So maybe I'll go back to, then this will be again 16 times 1. So I started 1, 2, 4, 8, 16. I'm going down that list. Now, this is duplicated. This portion is unnecessary. But don't forget, or I shouldn't even mention this yet, I will. Isn't it true that if you multiply two negative numbers together, isn't that also positive? Yeah. But I have to have a sum that's what? 17? No. What's 2 plus 8? 10? Yes. This is the pair. So you told me 8 and 2. Well, that's fine. But that's the same as what? 2 and 8. You okay with that? So some people in their head, they're going through this systematic approach. And then they find the sum the same way. Okay? This is what some people are really doing. Okay? You okay with this? You see what I'm saying? Now, what's the final answer? What are you guys going to say? X plus 2 times x plus 8. You're going to use the pair of numbers. This is step 3. Chicken soup. Yes? Doesn't matter. Could you put x plus 8 times x plus 2? Yeah. That'd be fine. Okay, you guys like this recipe? Huh? It's a factoring recipe. You guys are factoring. That's a big deal. You guys notice? Or you guys know that even when I teach calculus, you know, some students in calculus have to review factoring. Okay? Do I talk about factoring in calculus? Never. Do I talk about how to factor in intermediate algebra? No, not really either. When's the only time I talk about factoring? Right now. Let's see if you're awake. X squared plus 4x minus 21. Okay. What are your values for A, B, and C? I'm sorry, what's B and what's C? B, C, good. So I'll write this as my C value is negative 21 and my B value is positive 4. What pair of numbers I multiply together is negative 21, but when added is positive 4. 7 and negative 3? I don't know. Let's double check. Is it 7 and negative 3 that works? Okay, here we go. 7 times negative 3 is negative 21. What's 7 plus negative 3? 4. I guess you're right. Final answer. X. X. What numbers do you use again? The ones you just found. Plus 7 and minus what? 3. The values of B and C, what are they? B is -1. Good. What is C? Okay. So I write down C is my -48. B, -1. I need pairs of numbers. A pair whose product is -48, but whose sum is -what? 1. Okay. Does anybody have any pairs that work?
I have a question. Shouldn't C become -1?
No. C is what? 48. The form is x squared plus bx plus my constant. So, can anybody give me a pair? You guys find a pair here that works? Yes.
7 and 4.
7 and 4. What's 7 times 4? That's 28. This is -48. Well, let's see. Let's go through our procedure. And how do we do this again? Do we do this arbitrarily? Systematically. The benefit of doing this systematically is you could go through every possible pair and try to find it. Well, it's -48, so I know that it's negative. So one has to be positive, one has to be negative. So I'm going to start with 1, always. I start always with 1. What's 1 times -48? Is that -48? What's 1 plus -48? -47. Is that what I'm looking for? No. Okay. Now 2. 2 times -24 is -48. What about 3? 3 times what? Is that -16? What if I add these? Isn't this -22? And this is a -13. What comes next? 4. Notice 1, 2, 3, what? 4. I'm doing this systematically. I still haven't found my sum. 4 times, I guess it's -12. What's 4 plus -12? -8. 5. Does 5 work? No. 6. 6 times -8. What's that? It is -48, but when I add it, is that -2? You okay with this? So I'm starting from 1, and I'm working my way all the way down to what number? Probably 48. We'll see. Question? All right. What's the next number? 7? No. What about 8? 8 times what? -6. Isn't that -48? Do you guys see what's happening now? You guys notice what just happened here at this point. What happened here is kind of like the halfway point. Didn't I now just really switch the signs here? So by doing this systematically, isn't the signs all opposite? That's negative. This was positive. It's now negative. Negative. It's now positive. But what's my sum? +2. And then what comes after 8? What about 9? No. 10. 11. 12. 12 times what? A -4, because the product has to be a -48. What's 12 plus -4? Is that 8? All right, what's next? 13. No. 14. 15. 16 times what? Well, has to be a -3, because the product is what? Negative. What's 16 plus -3? Not 13? Does anybody start to notice a pattern here? Yeah, aren't you going backwards though? What's the next? I bet you the next one's going to be what? 24 times a -2. And then the last one's going to be what? 48 times -1. Let's do my addition. This is +22, and this is what? +47. Did I go through every pair of numbers whose product is -48? I did. How do I know? Because I went through this systematically, 1 through 48. If there's no pair, what do you guys think? We say this is what?
Non-factorable.
Not what? Factorable. If it's not factorable, then this thing is what? We also call that prime. No chicken? Yeah. You did chicken soup and, you know, something happened. But that's really the process. And you know, when I say that you have to go through how many problems? If it's 100, then you do the 100 problems. I mean, and that's just the only way about it. Here we go. X squared minus 8x plus 15. Let's try this one. Right? You go through this in what? B and what? C. Let's get C is positive 15. B is what? Negative 8. You need two numbers whose product is C and whose sum is negative, whose product is 15, sum is negative 8. What are the two numbers? Huh? What is it? Negative 3 and negative 5. Negative 3 times negative 5 is positive 15. Negative 3 plus negative 5 is negative 8. You got x minus 3, x minus what? 5. That's all you have to do for this. So go through your procedure, right? You got what? B, C, C, 28, B what? 27. So give me the pair of numbers whose product is 28, but whose sum is what? 27. What do you guys think? What's it going to be? What is it?
1 and 20.
You guys know? Is that?
Negative 1 and
Let me see. I want to double check here. Yeah. What do you guys notice? Right? If we go through the list. 1 times 28, that sum is 29. 2 times 14, that sum is 16. 3 times anything? No. 4 times 7, that sum's 11. 5, 6. Oh, 7 times 4, well, that's the same sum if I switch the numbers. Now, should I check the negatives? Isn't it true that negative 1 times negative 28 is positive 28? What happens when I add these? I get negative 29. The point I'm making is there's no pair. So here there's no pair. If there's no pair, this is not factorable. I always say this is really what? Prime.
Negative 1 and positive 28.
Negative 1, good. Negative 1 times positive 28. What's negative times positive? This is going to be negative 28, right? This is supposed to be what? Positive 28. So be careful. That is the hardest part. You might go, wait a minute, negative 1 times positive 28. You're right. But the product has to be a positive, not a what? Negative. Those are the small things that are going to happen that's going to get you. But you want to double check. Like I said, you can do this if you go through the practice. But it is vital, and I'll say this to people all the time. Remember that story I told you about that lady took what? Beginning algebra for 6 years.
Wow, that's a long time.
It's a long time, but here's what I'm saying. A lot of these processes boil down to arithmetic. Arithmetic, multiplication, and what? Addition, even signed arithmetic with negative numbers. If you don't master that, could you ever do that step by finding the pair? You guys see what I'm saying? If you don't know that arithmetic, then you're not going to be able to do the process. And that's my point to her. You got to learn the what? The arithmetic. If you did that, you're going to be okay with the process. So, like I said, you got to know the pairs and go through that arithmetic. And that's the only way you can go about it. You know, going through the pairs and numbers with the arithmetic. If there's a magic phrase, if somebody could ever say something to you to get you to be able to do this for the rest of your life, right? Then I would say it. I would tell you, oh yeah, this is what you always do. But this is really what you always do. It does involve work. But you know what? I mean, that's okay. How much time do you guys spend wasting doing nothing? You know what I mean? Anybody here on Facebook the whole weekend?
One time.
Once? Anybody here live on Facebook for the whole weekend? That's your life? If you're addicted to Facebook, what do you do?
No friends on Facebook, so.
You got no friends on Facebook? Why don't you friend me? I'll friend you. He's got no friends. Are you sure?
I got 0 friends.
Don't friend me because I'm going to bug you when you're going out or you're in Vegas. I'm going to say you better be studying. Don't show no Vegas photos and you're having a good time.
That'll be a good study tool.
A good what?
That'll be a good motivation.
To do what? Huh?
To like looking on Facebook and studies.
Oh no, I'm not your mom. I'm not going to be doing that. Clean your room. Do your homework. No, we can't do that. Whew. You kidding me? Boy. B and C. What is C going to be again? 32. What is B? You need a product who's 32, but a sum who's 12. What is it? Is it true 8 and 4 work? Let's see. 8 times 4 is 32. What's 8 plus 4? 12. X plus 8, x plus 4. Oh, let's make it really nice and hard. Okay, here we go. Can you guys tell me what B is? B is the number multiplied to X, right? Here's B and here's what? C? So C, negative 42, B, negative 1. So the product has to be negative 42. The sum has to be negative 1. Huh? What are the numbers? Remember, if it's negative, one has to be positive, one's negative. Because the only way you get a negative answer is if you multiply a positive with a negative as a product, right? That's the only way. So one's positive, one's negative. That's a big clue for you guys. That's why you guys have to see more and more examples and get more and more in practice. So what do you guys think? What two pairs of numbers, one positive, one negative, it's going to give you negative 42 and multiply together?
7 and negative 7.
Anybody know? You said 7 and negative 6. You're right. 7 times negative 6 is what? Negative 42. But what is 7 plus negative 6? When you add, it's positive 1. Is that right? That's not what you're looking for, but you're close. It's opposite. It'll be negative 7 and positive 6. Notice, isn't negative 7 plus 6 equal to negative 1? That's what you're looking for. This is your pair. So you have what? X, bless you. You got x minus 7 and x what? Plus 6. Okay, we're going to do some more tomorrow. But, you know, I would say to you, get started on some of these what? Problems. Factoring is a handout, and that's the section. We'll do some more tomorrow, and by the time Thanksgiving comes along, you guys will have a lot of examples to work with and a lot of material to kind of study, so you guys could get that done. All right? Anyway, okay. So let's go over this. If you guys notice, are these all chicken soup? How do you know they're chicken soup? Because chicken soup looks how? X squared plus bx plus c. So I have x squared minus 25x plus 144. X squared minus 2x minus 3. X squared minus 4x minus 12. X squared plus 8x minus 20. X squared, uh-oh. What happened to the x term? You guys remember? Put a what there? Put a ghost. You say, what do you mean a ghost? What's 0 times x? 0. What's 0 plus or minus anything? Well, it has no effect. Is that right? So it's not there, or it is there, I don't know. It's a ghost. Okay, the point is, they're of the form x squared plus bx plus c. This is going to be your chicken soup, okay? You guys okay with that? So the trick, first of all, is to notice what form you have, because then that tells you what recipe to follow. Now, remember the first step in this algorithm, this recipe? What did you have to do in that first step? What do your notes say? Find b and c. So b is the number multiplied to x. Here's my b. C is the constant value out here. Here's my C. Is that true? So this is what? B, what's this? This is? This is? This is? This is? This is? This is? Okay, so if I were you, maybe, you write that down. C is 144. B is what? What is B again? Negative 25. C is negative 3. B is negative 2. C is negative 12. B is negative 4. C is negative 20. What is B? 8. C is negative 100. What is B? 0. All right, you guys okay with these? So remember, step 2, what was step 2? What did they say? What pair of numbers? Find a pair, 2 numbers, whose product is C, 144, but whose sum is B, negative 25. What's it going to be? What did you guys get for the warm-up? What did you guys do? What were the 2 numbers? Okay, negative 16 times negative 9. Is that true? Let's see, what's negative 16 times negative 9 anyway? Is that positive 144? Negative times negative is positive. What's negative 16 plus a negative 9? It's negative 25. So what's the answer? Negative 16 and what? Negative 9. Everybody okay with that? So what's the final answer? What's step number 3? Use these values as your last terms. So your first term is x. First term is x. The last term's minus 16 minus what? 9. No. You can put negative 9 and negative 16 as well. Okay, this is your algorithm, this is your recipe. And it's all based on finding that pair of numbers whose product is C, whose sum is B. What two numbers multiplied together is negative 3, but when added is negative 2? Huh?
Negative 3 and 1.
Negative 3, positive 1? Okay, negative 3 times positive 1 is negative 3. Negative 3 plus 1, what's negative 3 plus 1? Negative 2. So the numbers are negative 3 and positive 1. Here we go. X minus 3 times x plus what? 1. And you're what? You're done.
I had it switched, that doesn't matter,
Um,
right? Like I had the 3 on the other side, and
what do you mean?
in the end right there, like x minus 3, I had x minus x plus 1, and then the other one was x minus 3.
Is that okay, you guys?
Yes.
Oh, just checking.
In other words, he's asking, can I put x plus 1 times x minus 3? The answer is yes. But notice your 3 has to be negative. Your 1 has to be positive. Same question over here. Can I put x minus 9 and x minus 16? Yes, you can. They both are, the same values. All right, you guys okay with that? This is factoring. It's a very big deal. So give me a pair of numbers whose product is negative 12 and whose sum is negative 4. What is it? Let's see. 2 times negative 6 is negative 12. 2 plus negative 6, is that negative 4? Sure is. The numbers are 2 and negative 6. X plus 2, x what? Minus 6. Okay, you guys okay with that? Is that easy or hard? Okay, good. All right, what about these? What about this one here? I'm going to erase some of this. Okay, I'm going to erase some of these things here. Let's see. What two numbers multiply together is negative 20, but when added is positive 8? Does that work? Negative 2, positive 10? Let's see. Negative 2 and positive 10? Negative 2 times 10 is negative 20. Negative 2 plus 10 is positive 8. Okay. Negative 2, positive 10. Okay, so what do you guys write down? X minus 2, x plus 10. Okay, you okay with these? What about this? What two numbers multiply together is negative 100, but when added is 0? Are there any numbers? There's none? You guys sure? There's no numbers? You can't find any numbers when I multiply together is negative 10, when added is 0? Negative 10, positive 10. Negative 10 times positive 10, is that negative 100? Negative 10 plus 10, what is that going to be? Is that 0? So the numbers negative 10 and positive 10, those are the pair. So this is x minus 10 times x plus 10. All right, you guys okay with this? What do you guys think? Anybody have any questions on these 5 examples? Okay, let me erase this here. Here's what I'm going to say to you, okay? Should we have you guys do some exotic problems? Do you guys know what exotic is? What's exotic? Out of the ordinary? Okay, let's do some exotic problems. What if you had to do the following? They want you to factor this. See if you're awake. 2x squared minus 50x plus 288. This is what I call exotic. Why do I call this exotic? Do you guys know? What does exotic mean? Out of the ordinary. So, how about this? Let's ask you guys this question. Is that chicken soup? It is? How do you know it's chicken soup? Really? Does this look to you when you use your eyeballs? Does it look like this? It's not chicken soup. So how come it's not? Yes, you guys see this value here? That tells you if you had this, it's chicken soup. That has to be x squared. In other words, there's really a number 1 out here in front of that x squared. Is that right? There's a number 2. It's not chicken soup. So I'll say this to you guys, not chicken soup. What if you have a situation where you don't have chicken soup? The question is, what do we do now? I'm going to say this to you guys. Here's what you guys want to try to do. I'm going to say, factor out the greatest common factor. In other words, it's that worksheet we talked about in terms of factoring out the greatest common factor. Do you guys remember what I'm saying? We need the GCF of 2x squared, 50x, and 288. Well, first of all, what was your process of finding the greatest common factor? You want the greatest common factor of 2, 50, and 288, meaning the numbers first, right? So what's the greatest common factor for the numbers? 2. Okay, good. What about the letters? I got x squared, I got x, and what's the story? There's no x. It's not even common. So that just means my greatest common factor is really just what? 2. Is that true? You guys see what I'm saying? Now, factoring out the greatest common factor meant we had to write our answer as the greatest common factor times a what? Quotient. Remember that? We know what the greatest common factor is. This is 2. The question is, what's your quotient? How do you guys find that quotient again? Okay, good. In other words, you say, I have 2x squared minus my 50x plus 288. This is divisible by the number what? 2. Got to divide by that greatest common factor. Now, 2 is dividing each term. So this is 2x squared divided by 2 minus 50x divided by 2 plus 288 divided by 2. I get x squared minus 25x plus 144 as a quotient value. So what this is, we're going to say this is equal to 2, the greatest common factor, times my what? X squared minus 25x plus 144. Okay, just to kind of remind you, what's the 2 again? Greatest common factor. What's this again called? Quotient. The process is called factoring out the what? Greatest common factor. Do you guys remember this? Okay, you had a worksheet on that. You had some bookwork on that. Now, here's what you guys do next. Did you guys notice anything here, by the way? Chicken soup. In other words, this we can factor by using the chicken soup recipe. That's the whole idea. Okay? You guys see what I'm saying? Now use chicken soup. Guess what? That was your first warm-up question. Do you guys recognize that? See your warm-up question number 1. You already factored this. In other words, the answer was 2 times. You already factored it. X, what was that? Isn't that minus 16, minus 9, you guys told me? Look at this. Ladies and gentlemen, you're done. That's the deal. So you got a little bit of exoticness, meaning that you gotta first factor out the greatest common factor, and what's left for these problems in this section is going to be chicken soup. Okay, so that's how you factor these kind of exotic versions. Okay, anybody have any questions on this one? You sure? All right, how about this? You ready for some more exoticness? How about, for example, they want you to factor 5x squared minus 10x. I think it's minus 15. Is this chicken soup? No. Why do we know it's not chicken soup? Anybody know? What's this number? 5. What do you guys see here? 1. Not chicken soup. So if it's not chicken soup, what are you guys going to try first? It's not chicken soup. What do you want to do? Factor out your what? The greatest common factor. That was a procedure. C, procedure, factor out the greatest common factor. It's in your notes. You had homework on that. So what's the greatest common factor of 5x squared, 10x, and 15? 5. Okay, good. So if I know the greatest common factor here is 5, I need my quotient, don't I? How do you guys get the quotient again? Take the problem, 5x squared minus 10x minus 15. Divide this by my greatest common factor, which is number 5. Okay, now the 5 is dividing 3 terms again. What do you end up getting? X squared minus 2x minus 3. Here's my quotient. Okay, and then again, the form is going to be 5 times x squared minus 2x minus 3, where you have greatest common factor and the quotient, in which you now do what with the quotient? Don't you factor that quotient? Do you guys notice? What procedure do you use to factor the quotient? Chicken soup. And that's actually warm-up question number what? 2. You did that one already. Okay? And so, let me do this. Let me write this answer on top here. It's going to be 5. Okay, what did you do when you factored this? X, what else? I think, wasn't that x minus 3, x plus 1? You are what? You're done with your factoring strategy. Isn't that a little exotic here for you? Yeah, let's see. Okay, you guys okay with this? Anybody have any questions on that one? No? Here we go. Let's do some more. 4x cubed minus 16x squared minus 48 what? X. Is that chicken soup? How do you know this is not chicken soup? Yeah, take a look. That number is a 4. That's not 1, right? Then what do you know about this x? It's to the third power. It's supposed to be the x to the second power. That's not chicken soup. So if it's not chicken soup, what's your strategy? Factor out. I'll even write it down again. You know what I suggest on your homework? Do it the same way. Factor out the what? Greatest common factor. So if you do, like, oh, how much homework problems is this going to be? About 90 factoring problems to do. You wrote it down maybe whatever, out of the 90, maybe you wrote it down 45 times. Do you think you're going to forget? Okay, you're training yourself to go through this procedure. So, but you have to know also the greatest common factoring procedure. So we need the GCF. What's the GCF? Of 4x cubed, 16x squared, 48x. Notice x is common again. So that means my GCF is going to have an x. But how do I do that? How do I find that greatest common factor? I look at the number first. 4, 16, and 48. What's the greatest common factor? Okay, x cubed, x squared, and x. Elisa, what is it? X cubed, x squared, and x. What's your greatest common factor? X. Do you guys remember, wasn't it x to the what? Smallest power? You guys remember? So clear out those cobwebs. That's my greatest common factor. It's x to the smallest power. 3, 2, and what? 1. Go look over those notes. It's only going to benefit who? You. How do you get the quotient? You take 4x cubed, right? Minus 16x squared minus 48x. Divide by what? X, you get what? 4x cubed over 4x minus 16x squared over what? 4x minus what? 48x over what? 4x. What happens here? Remember this division homework you guys work with? Some division homework? What do you guys get now with this? What's this? Isn't that x squared minus what? 4x minus what? 12. So ladies and gentlemen, this is my quotient. So you get 4x times x squared minus 4x minus what? 12. And once again, greatest common factor. Once again, you factor the what? The quotient. Isn't this chicken soup? And isn't that warm-up question number what? 3. So, how do we factor this one? Wasn't this 4x times, what do you guys get? Is it x plus, is it x plus? X plus 2, what else?
That's our answer, the 4x.
Yeah, don't forget, you need that 4x times. So you guys know what you're going to have? What happens if you multiply everything out here? By the way. What do you got? What happens if you multiply the FOIL and you multiply the answer by 4x? You get this. Okay, you guys okay with this one? Check the warm-up number 3. What do we say for warm-up 3? Two numbers multiplied together is negative 12. But when added is what? Negative 4. The numbers are positive 2 and what? Negative 6. 2 times negative 6 is negative 12. 2 plus a negative 6 is negative 4. So in other words, go back to that procedure where you find the product of two numbers and the sum. Okay, you guys okay with this example? This is, let's try this. Now let's see if you're really awake. This one is going to be, this is one's going to keep you up at night, right? What do you guys notice? Is that chicken soup? What do you got to do? Well, before you do the ghost, before you think of a ghost, what do? You guys noticed you're going, aren't you following your procedure? You just skipped your steps. Not good. Anybody going to cook a turkey? You're going to cook a turkey? Are you sure? For Thanksgiving, you're cooking turkey? How do you do it?
You just prepare it. Well, for me, I put it in the oven bag. That's how I make it. Then by the time it's like 2 hours cooked, I just take off the bag. But, yeah.
What if you actually leave the bag off and cook it, and then you put the bag on after?
That's how my mom did it.
I understand. But what if you were to change the procedure? In other words, what if you guys sat there and said to me, ghost? There's no ghost yet. You just took the turkey out of that bag. See what I mean? What do you do first? Factor out the what? If you notice this is not chicken soup, factor out your greatest common factor. What's the greatest common factor of 5x to the fourth and 500x squared? Good. Greatest common factor, 5 and 500 is 5, x to the fourth and x to the second power. What is it, Elisa? X to what power? What's smaller, 4 or 2? How do you get your quotient? Divide 5x to the fourth minus 500x squared. You divide that with your 5x squared. That's 5x to the fourth over 5x squared minus 500x squared over 5x squared. What's your quotient going to be? X squared minus what? 100. This is the quotient. So this problem here becomes greatest common factor of 5x squared times the quotient of x squared minus 100. So I'll write it down. Greatest common factor. Quotient. What do you do with that quotient? You factor that. Okay? And then, let me ask you this. Now could you think of the ghost?
Yes.
All right. What's your procedure for Thanksgiving? Do you stuff the turkey before you cook it?
Sometimes.
I'm putting stuffing in it. They put like different spices and stuff.
Okay. How about what do? You cook the turkey? What else do you do? Stuff the turkey? After you cook it? Maybe you stuff the turkey first, then you cook the turkey, and then what do? You let the you let the turkey cool?
Yeah, let it sit.
Let it sit?
Because or else it'll dry out if you cut it too soon.
And then what do? You eat the turkey. What if you start going out of the order and you eat the turkey first before you cook it?
I like to eat the turkey dry.
Before you cook it?
No, after.
What's my point? Now you can talk about a ghost. Is that true? In other words, when you factor this is x squared. Here's my ghost, 0x minus 100. Now you talk about it, okay? Look at all the work you had to do before you got there. Don't go out of what? Order, okay? Because you're not going to eat your turkey before you cook it. So then, if you factor this, we already did. See warm-up number what? 5. Look at that. 5x squared, x minus 10, and what? X plus 10. Look at that. We're dealing with some exotic situations. Okay, anybody have any questions on this one? You sure there's no questions on that? Should I show you another type of exoticness? Do you guys like exotic problems? No? You got to do them though. Here, how about this? See if you're awake. This one's pretty tough. All right, this one's pretty tough. So what are you guys going to do with this one? Should I tell you guys a secret here how you handle this? Okay. What do you guys notice though? Don't you have x squared? What else do you have? 8xy. Notice the powers for x and y are 1 and 1. And you got this 20 and you got y squared. Do you guys know what that kind of looks to me in some ways? That looks a little symmetric. You say, what do you mean by that? Well, for your x, you went from power 2 to power 1. And then from your y, you went from power 1 to power what? 2. So if I'm in that situation, you guys know how I factor this? I like to keep things really simple. I'll tell you the secret, okay? If I tell you the secret, you have to not tell anybody. Because you have to keep the what? Secret. Anybody here have any secret? You have any secrets?
I do.
Do you have any secrets? No? Should we? Secrets? Do you have any secrets? You?
Well, if I do, I would never tell.
Oh, okay. Don't tell anybody. Does everybody have secrets? And some people more than others. Except for Elisa, she has no secrets. Shh, don't tell anybody this. Don't even think about the y term. In other words, my secret is to factor x squared plus 8x minus 20. I just forget about my y term. It's not even there. That's my secret. Now, we factored this already. This is warm-up question number 4. What did you guys get when you factored this in blue? What did you get? Get x. I think, was this, what was this? Is it x minus 2 and x plus 10? Okay. So I factor instead of the top one in black, I factor the blue one. But then I have to remind myself. Like, okay, but that's really not what I have. What do I really have? The y is here. Is that true? So I write down my x minus 2 and my x plus 10. Okay? And then I put my y back. All right, you guys okay with that? Yeah, let me show you why. Note. Let's show you why this works. Remember, what was factoring again? It was the reverse of what? FOIL. So let's note that if I take x minus 2y times what? X plus 10y. X minus 2y. X, 10y. Wasn't this FOIL? Let's go through the process of FOIL. This is my rows. Here's my columns, okay? So let's go through this. Multiply my rows with my columns. Remember we did this here? You even had a test on it, I think. X times x, what is this? This is my first terms. Isn't that x squared? And then x times 10y, isn't that just 10xy? X and your negative 2y, isn't that minus 2xy? And then negative 2y times a 10y is a negative 20y what? squared, ladies and gentlemen. In other words, first terms is x squared, outer terms is 10xy, inner term minus 2xy, last terms minus 20y squared by FOIL. You're using the FOIL process to multiply. First, outer, inner, and last. And if you remember, what do you guys remember? Those terms are what? They're like. So what do you do when you have like terms? You combine them, you add them. If I owe 2 bananas and I have 10 bananas, what's my story? I have 8 bananas. Don't forget, this is a whole other term. What I'm saying is you are done multiplying by FOIL. Isn't that what we had here to begin with? Now, I'm just demonstrating to you that factoring is the reverse of FOIL. This statement here is equal to that statement. Okay, you okay with this? So what I'm demonstrating to you guys is the following. If you have this symmetry with two variables like x and y, what do? Forget one of those variables and factor like you already know how to do by chicken soup. And then with the answer, what do you do with it? Add your y's. That, ladies and gentlemen, is your what? That's your process. What do you guys think about that?
Only if they're symmetrical like that?
Yes. So a lot of times they do, and this is, like I said, this is the derivation I try to demonstrate to people. Say, hey, look at this, use FOIL, and this is what you get. You know? So, I mean, this actually happens. You know, people will give you these kind of problems. So let's take a look at this. I'll say, what if you had this? You had to factor x squared minus xy minus 2. Now I want to point out, 2y squared, sorry. I want to point out to you, this is not chicken soup exactly, right? Well, kind of, but let's see. Do you guys notice that symmetry that I was talking about? X squared and then x to the first, and then y to the first, and what? Y squared? What do you guys do in this case? Factor what? Factor the x squared. Oh, look at that. It's gone. It's my favorite blue as well. Here we go. What do you guys do with this? Factor your x squared, right? Forget about the y. Forget about this y here. Factor that instead. What recipe is this? It's chicken soup, ladies and gentlemen. You say, how do I know it's chicken soup? Does it look like this? Sure does. That's how you know. Okay, my recipe, I got a B and I got a C, and I think, okay, C is going to be -2, right? What is the value of B? Is it +1 or -1? So what's my process in chicken soup? Two numbers multiplied together is -2, but when added is -1. What is it? Is that true? Let's check. -2 times +1 is -2. What's -2 plus 1? Is that -1? So the answers are -2, +1. You're right. So this is going to be x minus 2 times x plus what? 1. Is that right? And then, what do you guys notice? What's the final answer? X minus 2, x plus 1. What do you guys enter here now? Your y. Good. Now, do I have to put one y, or can I just put y? Okay, good. You're what? You're done. So this is how you factor when you have this symmetry involving a second variable. What do you guys think of this one? You guys thinking of a ghost? What do you guys think? You guys believe in ghosts? I can show you ghosts are real. Huh? Here's a ghost. It's real. 0 times x times y is really what? 0. So it's not even there. Do you guys notice the symmetry? Okay, if you notice the symmetry, what do you factor again? You're going to factor x squared plus 0x minus 16. In other words, forget about your y term. And when you do, we look at this and we say, this is chicken soup. My b term, my c term, my c is negative 16, my b is 0. I need two numbers multiplied together is negative 16, but when added is 0. Negative 4 and what? Is she right? It's negative 4 times 4, negative 16. What's negative 4 plus 4? So in blue, I know that this thing is factored as x minus 4 times x plus 4. But I can't forget that this is not my original problem. My original problem involves my what? The y. Y squared there and y squared. How do you fix it? X minus 4, let's see. X plus 4. What do we infuse here? A y and a what? A y. Is that pretty exotic? What do you guys think? Do you guys like that? Anybody have any questions on these? You sure? So you're going to try this problem, you're going to try this problem. How about this?
Sorry.
So I'll give you guys a few minutes to try these last exotic versions. So minus x squared plus 5x plus 14. Okay, I'll give you guys a few seconds to try these three all on your own. Try this first. Try this second. Do it in the order I wrote it down and leave this one to last. See what you guys can do with this. I'll give you a few minutes and then we'll go over it. So. Okay, you can test yourself on these processes. Okay, here we go. Let's try this first one in the middle here. You guys remember, what do you have to think of again? You have to factor x squared minus 5x minus what? Minus 14. So, what recipe do you guys use? Chicken soup. Okay, so you have to tell me what two numbers multiplied together is negative 14, but when added is negative 5. Negative 7 and positive 2. Is that true? Negative 7 times 2 is negative 14. Negative 7 plus 2, negative 5. So here we go. We're going to factor this. What do you guys notice? Isn't this now what? X minus 7 and x plus 2? What's your final answer? Right, it's going to be x minus 7, and then we got what? X plus 2. Don't you need your y's? You guys okay with this one? Anybody have any questions on this? All right. What's the hardest part? Huh? Doing the work is the hardest part? What do you mean? Huh? What do you mean? Do you see the symmetry? So then think of what? Then that's chicken soup. See what I mean? And once you know it's chicken soup, follow your chicken soup recipe. Now, like I said, if you think, for example, that you're going to get this without practicing, do you guys know there really is no magic words anybody in this world can use to you to say, oh, you'll remember how to do this forever. Oh, is that how you have to do? It's not like those other courses you guys take. Some of those other courses you take, what? Maybe you remember. I don't know. But what I'm saying is there is a process to follow. You follow that process. And when you first learn it, it might be, wow, this is a whole new idea. It is for some of you. But go through your process repetitively over and over again. How many problems do you have to do again? Enough. For you, maybe it's going to take what? 100. Or maybe it takes 50. Or maybe it only takes 20. Maybe it takes 200. You do really enough. And you'll get to where you're going. That's the whole idea. Yeah.
Will it be wrong if you put x plus 2 first?
No. Okay. Now let's try this one. What do you guys notice about this one? Is that chicken soup? No. Notice it's not chicken soup, right? So what do? Factor out the greatest common factor. You guys notice every time I had to do it, what did I have to say? I mean, I'm even write this out. Factor out the. If I can write it down, can't you? Will your hand hurt? My hand always hurts. Imagine all this writing I do. Boy. What's the greatest common factor? You guys okay with that? So, what's the process? You determine your quotient by doing your division. All right, so you're going to divide now by my 3x. You end up getting 3x cubed over what? 3x minus 15x squared over what? 3x minus 42x over what? 3x. And what do you end up getting? X squared minus 5x minus 14. Good. So, what you now have really is, this is the greatest common factor times the quotient. What do you guys notice about that quotient? You can factor by using what? Chicken soup. In fact, you actually did it already. It's right here. Okay, you guys did it. So I'm going to put the answer right on top. The answer is going to be 3x times x what? Minus 7 times what? There you go. This is your procedure. What do you guys think of that? It's your process. Anybody ever here build a house?
I built a boat.
You build a boat? Really? Did it float?
Of course.
It did. How'd you build the boat?
Just got a piece of wood and it's just like cut with a paper saw. I use a hammer and I use nails on it and just assemble it.
That sounds like too much work. It's too much work.
It is.
Too much work.
Took me like 2 weeks to make.
2 weeks? That's too. Oh, took you 2 weeks? This takes you only 2 minutes. Too much work. Anything that's significant takes some work. So, okay. How about this? A boat. Imagine if people decided too much work to build a boat, too much work to build a house. We'd all be homeless. We'd be sleeping under trees, I guess. All right, negative x squared plus 5x minus 14. I'm going to tell you guys, is this chicken soup? Why is that not chicken soup? This is a negative what? 1. Let me say this to you always, always, always. In mathematics, we hate to factor when that leading coefficient is negative. It's like, oh no, it's negative. You guys know how you fix this? I'm going to say factor out the what? Negative 1. You go, how do you factor out negative 1? Very easily. Determine your quotient. You say, what do you mean? Well, this is x squared. Remember, it's minus. Plus 5x plus 14. Divide by what? By negative 1, because we're going to find the quotient. This is my quotient. So I'm going to write this as negative 1 times a quotient. Okay? So here we go. We're going to have negative x squared over negative 1 plus 5x over negative 1 plus 14 over negative 1. What's negative divided by a negative? It's x squared. Positive divided by a negative. Positive divided by a negative. Here's my what? That's the quotient. Now, I'm going to say this. Let me erase this. So now here we go. Let's write what this is. This equals my negative 1 times my quotient of x squared minus 5x minus what? Is that minus 14? So here's the negative 1. Here's the quotient. You factor your quotient by using the method known as what? Chicken soup. Have you factored this one today? Yes, you did. Final answer. Negative 1 times x minus 7 times x plus 2. Do you have to write the negative 1 down? Yes, you do. You need that there. Believe me. You say, why? Because if you were to multiply everything out here, even with the negative 1, you have to have that negative 1. Then it'll be negative 1x squared plus 5x plus 14. Now, I give this to you because I think some questions on your homework have that negative 1. Do you guys notice? So I want to give you guys a hint. If that first term's negative like that, we don't want a negative. You factor out the negative. Should we do one more? You guys ready to do one more? Here we go. Last one for the day. And then you guys are really good for your homework in that worksheet. And wow, you guys on your way for factoring. Here we go. Minus x to the fourth. Plus 132 x squared. I took this from your book. Okay, here we go. What do you guys notice? Chicken soup? No. Is there a negative? All right, I gotta factor out that negative sign, right? What else do I notice? Greatest common factor. Good. X to the fourth, x to the cubed, x squared, x to the what, Elisa? X squared y. Why is it x squared? There, see? Let's find our quotient. You're going to factor, let's get that quotient. You got negative x to the 4th power minus x cubed plus 132x squared divided by negative x squared. It's negative, the negative 1, and the greatest common factor. Okay, so this is kind of the greatest common factor with your negative sign. So let's get the quotient here. This is what it is. Minus x to the 4th over negative x squared minus x cubed over negative x squared plus 132x squared over what? Negative x squared. Here we go. Negative divided by negative is? X to the 4th divided by x squared? X squared. Minus divided by minus? Plus. X cubed over x squared? X. Positive divided by negative? Negative. X squared and x squared cancel. 132. So, let's write this down. My negative x to the 4th minus x cubed plus 132x squared becomes negative 1 times what? Or not negative 1? Negative x squared times x squared plus x minus 132. I have to use what here? Chicken what? Soup. Where B and C, let's see what C is negative 132. B, what's the value of B?
1.
Don't tell me it's x. It's the number multiplied to x, which is a what? 1. Okay? It's the number multiplied to x. You go, I don't see a number. Well, you see one now. It's 1 times x. What two numbers multiply together is negative 132, but when added is 1. One's positive, one's negative. What do you guys think? 12 and negative 11. Is that true? Positive times negative is negative. Do you guys know what 12 times 11 is? It's 132. What is 12 plus negative 11? 1. Here we go, ladies and gentlemen. You're going to earn your turkey this year. X plus 12 times what? X minus 11, ladies and gentlemen. Here you go. There it is. You guys are now clear to complete your homework assignment. And what are we going to talk about tomorrow?
Factoring.
Beef what? Stew tomorrow.